Today we are going to once more divide a polynomial by a binomial. However, this time, on some of the problems, we won't be able to find common factors, but we should always look for that first. So looking at this first problem, we can go ahead and see if it factors the polynomial up top. And remember, this is the same thing as c squared plus 7c plus 12 all over c plus 4. So if the numerator has a factor of c plus 4, we can come up with the answer fairly quickly. And so I see c plus 4 times by c plus 3 gives me the factored form. 3 and 4 multiply to make 12, and they add to make 7. So in this case, I could easily just cancel out those c plus 4s and come up with my answer. However, on other problems that you'll see on tonight's homework, it's not going to be that easy. See, if I go ahead and factor this, I have a plus 3 and I have an a plus 1. Well, here, down below, I just have an a plus 2, and they're not the same, so I cannot do any canceling. So we have to come up with another way in order to divide these polynomials by this binomial. And so what we're going to end up using in this class is a method called long division. It's very similar to the long division you used when we just divided numbers. And so we're going to use the same technique. Later on, there'll be other methods to use, but that's what we're doing here. And this kind of gives you the basis idea for the other methods. And so here we have a plus 2. That's my divisor. Divisor always goes outside the box. And inside this box goes the dividend. And that's the polynomial in this case, a squared plus 4a plus 3. And here's what we're going to do. We've got a that we're going to multiply by a number up here to make an a squared, to kind of cancel this term out. And another thing you should notice is that when I put a number on top in the quotient here, it should have the same exponent as the number that the dividend has. And so my first number I'm going to end up putting up is an a, because I want to cancel out this a squared. So what I do now is I multiply a times by a, and I get a squared. And then I do a times by 2, and I end up with a positive 2a. Now I'm going to end up subtracting these numbers. Now when I subtract, remember, that's the same thing as adding the opposite. And so I'm going to do that. I'm going to change it to an addition problem right now. So plus negative, and this will become a negative as well. And so remember, you got to subtract both numbers here, and when we do that, this is what we get. Well, these cancel out to make 0. That's what we want to happen. Over here, 4a minus 2a makes 2a. And then in long division, we typically bring down the next number. That's what we're going to do here. Bring down the 3. Now, we're going to put a number up here. Now remember, it's going to be a constant, just like this one is here. So the number is going to be the same. Not necessarily a 3, but a number like a 3 or a 2 or a 4 or a 5. Some sort of number that when I multiply it by a, I get 2a. That's what I'm trying to do. And so we go ahead and think about that. A times by 2, positive 2 makes 2a. And then you do the same thing here. 2 times by 2 makes the 4. And then we go ahead and subtract. But remember, when you subtract, that's the same thing as adding the opposite. So it changes to plus negative, and this to a negative as well. And then we can go ahead and do some subtraction. So these cancel out, which is what we want to happen. We end up with a remainder of negative 1. So the way we show that is we take that remainder and we add negative 1 over the divisor, a plus 2. And that's our answer right there. So that's the quotient. So again, the key is just like long division, we always try to cancel out that leading term to kind of narrow our way down to the end. And instead of a decimal, we're going to just use the mixed number form. And so negative 1 over the divisor of a plus 2. Take a look at the next one. Very similar problem. You see, always check to see if you can factor and to cancel. So n plus 3, n plus 5. That's the factored form, but it does not cancel out that n plus 4. So what we're going to end up having to do is use this long division method. So here's how we'll do it. We'll take that n plus 4 and put it outside this fraction bracket and put the n squared plus 8n plus 15 inside the box. And so from there, we'll go ahead and do some division. So again, we put the number that we're going to start with is going to go here because we're trying to cancel out the n squared. And then we're thinking of n times what makes n squared? N. That's it. Notice that they have the same variable raised to the same power that's gonna be right on top of the other. So this has an n, this has an n. So that's why it goes here. So n times n makes n squared. N times by 4 makes 4n. And then we subtract. But when we subtract, remember, add the opposite. So plus negative, and this changes to a negative. And then from that point, we can go ahead and do that subtraction. See what we end up with. See, the n squareds are going to cancel. We're left with a 4n. Bring down the plus 15. Now the whole idea is to cancel out a 4n. So we're trying to think of a number that's going to go up here. And it's just going to be a number like 15, that when we multiply by n, it makes 4n. Well, that's going to be a plus 4. 4 times by n makes 4n. And we go ahead and multiply 4 and 4, we get 16. We go ahead and subtract, but remember, add the opposite. You'll see in the next problem why it's real important to make sure we add the opposite. And so we go ahead and do that work. We end up with a negative 1 once more. So our answer, our quotient, is n plus 4 plus the remainder, negative 1 over the divisor, n plus 4. And that's our answer. So this one's a little more challenging. So same sort of thing. Always look to see if you can factor this out. But we go ahead and try it. And I would end up using this as one of the factors, because if it does factor, it's got to have 2n plus 1 as one of the factors to cancel. So the other one would have to be a 4n minus 7. And when I check this, this makes 14 minus 4 does not make 6. So no, that does not end up working. And so what we have to do is use that long division method. And so always, again, check, because sometimes like this one here, we were able to do the factoring and then come up with our answer quickly. So here we've got 8n squared minus the 6n minus the 7. If you leave a little more space between the terms, sometimes it's a little easier to see what's going on. So the whole idea is to multiply 2n by some number to make 8n squared. Well, 4n times 2n makes 8n squared. So that's the number. And notice that it goes right above the 6n. So we end up with an 8n squared, and then 4n times 1 makes positive 4n. We go ahead and subtract. Now here's where it's important to add the opposite, especially on this problem. So plus negative, and this becomes a negative here. And so when I do the subtraction, I end up actually adding the next number. See, these end up subtracting, but these are the same sign, so I end up adding. That's why it's important to make sure you add the opposite. Bring down the minus 7. We only have one more number to go, and then we're done. And so we're going to go ahead and look for the number times 2n that makes negative 10n. Well, that's just a negative 5. See, we want to make the same number there. Negative 5 times 2n makes a negative 10n. Negative 5 times by 1 makes a negative 5. We add the opposite. Remember, so we change it to subtraction. We're going to subtract, but then we're going to end up adding the opposite. So I'll do that right now. Plus, and then this becomes a positive, this becomes a positive. And you'll see how we can end up subtracting these 10n's now. We end up with negative 2 as the remainder. So we just write our answer as 4n minus 5 plus negative 2 over the divisor, 2n plus 1. So those are the types of problems that you'll end up seeing on the first half of the homework. Part 2 will have some problems similar to the second part.